Aha! Welcome, people. When I know the station now, Maths Pidgin. The name never change. Mr. Maths. So for our last class, we will do lots of indices. So now the laws be this. Abi? We will say if A raised to the power x times A raised to the power y, make we add the indices. Abi? We can call them the addition law. That is additional law of the indices. And then for the number 2, we say if A raised to the power x can't divide A raised to the power y, we could subtract y from x. Now wetin we call subtraction law. Then for the third one, we can say if I raise A to the power x, can't raise them again to the power y, say we could multiply the indices. So we can call it multiplication law. For the number 4, we can also say any number raised to the power 0 is 1. We can call it 0 index or 0 index law. 0 index law. And then we can get fractional index. If we raise power to 1/2, we could take the square root of the number. Did I say if we raise power? If we raise number to 1/2, we could take the square root of the number. Then number 6, another fraction. You say if I raise number to x over n fractions, say make I do it, take the nth root of a raised to power x, or make I take the nth root of a, come raise my answer to power x. That one too, na fractional indices. Then we can talk about negative index law. Negative index law. That one, if I raise power to negative indices, then I will just take the reciprocal of the number raised to the nth power of the number. Now, we could take exercise. The exercise we want to take for this class. See few exercises what we get. So this one says simplify the following. So I get 3.6 times 10 raised to the power 7 divided by 1.2 times 10 raised to the power 3. Abi? So what will happen now? If I get 3.6, solution bar to number 1. 3.6 times 10 raised to the power 7 divided by everything. Divided by 1.2 times 10 raised to the power 3. Like this. So another way, what would you express this thing as something like this? Times 10 raised to the power 7 over 1.2 times 10 raised to the power 3. Abi? We will use our law of indices, or we will use algebra. Anyone way you use will give you the same answer. Abi? This one, if we come out this point, we'll get 36 over 12. Abi? 36 divided by 12, we'll get 3. Abi? We can do it like this. 36 divided by 12 times, Abi? I get 10 times 10 times 10 times 10 times 10 times 10. Then I can divide by 10 times 10 times 10. Abi? So now 36 divided by 12 will give me 3 times this one will cancel. So I get 4 bar. And what do I get? 1, 2, 3 times 10. So I will get 10 raised to the power 4. So that is my answer. If you don't want to go like this, if you use the law of indices, as we don't get them from here, we can say this divided by this, I will get 3. Then I will come do times 10 raised to the power 7 minus 3. Then I will get 3 times 10 raised to the power 4. Using the number 2 law. Abi? This one, the number 2, so we can simplify 32 raised to power 3 by 5, like this. So if I get 32 raised to power 3 over 5, means say make I take the 5th root of 32, then come raise everything to power 3, like this. So the 5th root of 32, now 2 raised to power 3. Somebody will say, take no. I'll be no like that. You get. But if you do one for calculator, you go get them. So, but what it means say, I get 32 divided by 2, I'll get 16. Divided by 2, I'll get 8. Divided by 2, I'll get 4. Divided by 2, I'll get 2. So, I'll count my 2. 1, 2, 3, 4, 5. So, as I've been for my former class, I've been not explaining square root, roots of numbers. So I get 2. So if I multiply 2, or if I raise 2 by 3, 2 times 2 times 2 by 3. From our last class, we know saying 8. Abi? So the answer na 8. Another way we will fit one. If you say 32 raised to power 3 over 5 like this. So it's either we say the 5th root of 32 raised to power 3 like this. Then we can say the 5th root of 32 raised to power 3 will give us 3, 7, 3, 2, 7, 6, 8. I hope so you know the short calculator. Okay, 32 raised to power 3 will give us 32768. Abi? If we take the 5th root of 32768, we'll get 8. That's another way. Oh, we go. Abi? The next one, say what we do. The next one, say 25 raised to power 1.2. 1.2 will be 1.5. 1.5. No, 1.2. So 25 raised to power 1.5. Then from here, this one a fraction now. This is fraction expressed in decimals. So we can change it. We go say 25 raised to power 115 over 10. So we understand. If I get something like this, I want to change that to fraction, I will just move this one. I'll put 1 for that like this. Then move this one place, I'll get 0. That's what I did here. Abi? Then we'll have 25 raised to power 5 here, 3, 5 here, 2, Abi? So we don't get 3 by 2. Go? Then from there, we'll use our fractional indices. We'll get the square root of 25 raised to power 3, Abi? So what will happen? We'll have square root of 25 is 5. Abi? 5 raised to power 3. 5 raised to power 3. So if we raise 5 times 5 times 5. From here, 5 times 5, 25 times 5. Right? So what thing will happen? If I multiply this 1 by 10, I'll get 250. But I want to multiply them by 5. So by 10, 250. Then I'll divide them by 2. I'll get 125. So that's my answer. So from here, we have negative indices. So wetin this one mean na 1/2a, like this. Then times 3a squared. If I multiply this one and this one, I will get 3a squared over 2a. Abi? So this one will cancel this one. I will get 3 over 2a. That's my answer. And then the next one say that's 5. I get 2a raised to power half times 3a squared. This one is Yoruba, but they are not the same thing. So from here, I'll get 2 times 1/a. The meaning of this one is that times 3a squared. Abi? So if I multiply these ones, I will get 2 times 3 times a squared over a. So from there, this one will cancel this one. This times is 6. So my answer is that. You should continue, bro. Solve the following exponential equation. This one is a simple equation. So I have 2 raised to power x equal to 0.125 like this. Then I get 2 raised to power x. Then I'll turn this one to fraction, Abi. So I will pick this ones 125 like this. Then in place of this dot, I'll put 1. Then I'll put 0 according to the number of these digits. I'll get them like this, right? Now if you use calculator to do this thing, you'll get 1/8. Now, if you don't want to use calculator in case of those where they write jam, you see say 5 will go here and 5 will go here according to rule of division. Abi? So now, if you divide this one by 5, this divide by this 125 divided by 5, I'll get 12 by 5. I'll get 2, remainder 2. I'll join the 2 with 5. I will get 25. 25 by 5, I will get 5. Then 5 here. 1000 divided by 5. I get 10 divided by 5. I will get 2. Then I get 0, 0. Abi? Now 5 here 2 will give me 5. And then 5 here, I get 2 here, I will get 40. Abi? Because 20 divided by 5 will give me 4 plus 0. And 0 will give me 40. And then 5 here, I will get 1. 5 here, I will get 8. So from there, I get 2 raised to power this 1/8 like this. Cool? Now from our law of indices, if we get something like this, so we can say 1/2 raised to power 3 like this. Abi? Now from our law of negative index, our negative index says if we get something like this, say something like this means negative index. So I get 2 raised to power x. We can't give me 2 raised to power minus 3. That's law of negative index, ba? Now, what thing happen as I get the same base, the base go cancel. So I'll get x is equal to minus 3. Now the answer is that. Abi? So we could do number 2. Number 2 say I get 3 raised to power minus x equal to 2, 4, 3. 2, 4, 3. It's 2 now. So now I go my clue now, make I know how many times I go raise 3 or to how much power I go raise 3. We will give me 2, 4, 3. Abi? So if I take 2, 4, 3, divide by 3 like this, I get 24 divided by 3 will give me 8 ba. Then 3 by 3 will give me 1. Then if I divide this one by 3, I will get 27. Yes. And then 27 by 3, I will get 9. 9 by 3, I will get 3. So that means from there we have 3 raised to power minus x is equal to 3 raised to power 5. Abi? Then it follows that this one will cancel this one. We have x minus x is equal to 5. So multiply both sides by negative sign. So I will get x is minus 5. That's my answer. So 25 raised to power 5 x is equal to 625. So from here, I get this. Then if I take this one, divide by 25, I'll get 25. If I divide that by 25, I will have 25. So that means that 25 squared is what I get here. Then the base can cancel, so I have 5x is equal to 2. And I'll divide both sides by 5. Abi? I'll divide both sides by 5. My x is equal to 2 over 5. That's another way to do it. So I get 4 over 2 raised to power x equal to 64 raised to power x. That's another way of doing it. So now let's do the maths. Cool? So from here, I can separate this one. I have 4 times 1 over 2 raised to power x equal to 64 raised to power x. Abi? What did they happen? From here now, I can have 4 times, this one show me a negative index bar, so minus x like this equal to 2 raised to power x like this. Then I can take the base to be 2, all the base to be 2. So I can have 2 raised to power 2 like this times 2 raised to power minus x like this is equal to 64 will be 2 raised to power 6. Abi? Raised to power x like this. Then I can now do this one. This one say the first law say if I get the same base, make I add the power. So I have 2 raised to power 2 plus minus x like this equal to, then multiplication law say make I multiply these two. I have 2 raised to power 6x. Abi? So from here I can cancel the base. Abi? So I get 2 plus or 2 minus x is equal to 6x. Abi? Then from here, we can collect like terms. Abi? So we add x to both sides. So we have 2 is equals to 6x plus x. Then we have 2 is equal to 7x. And then we divide both sides by 7. I have 2 equal to 7x. Dividing both sides by 7. Like this. So we have that x is equal to 2 over 7. I hope say this class makes sense. So that's how you solve equation using indices. See you next class.